Let's talk about domain and range and also interval notation. So officially, for any relation, typically we're working with functions, but not always. Its domain is going to be all the inputs that it uses, and really that's all possible inputs, right? So if it's a formula, it's not just the x values you chose to plug in, it's anything you could possibly plug in. And then the range is all possible outputs, so similar idea, but it's the y values or outputs. So for pretty much all of our domain and range problems, they're going to ask you to write your answer in interval notation. So before we do any domain and range problems, I just want to take some time and talk about interval notation in case it's something that you haven't seen before or in a long time. All right, so interval notation always has a symbol, number, comma, number, and then another symbol. So on either edge, the symbol is either a bracket like this or a parenthesis. And then over here again, bracket or parenthesis. They don't always have to match. You can have like a bracket over here and a parenthesis over here or vice versa. And then the two numbers will represent the lowest in the interval, comma, the highest in the interval. So if you're trying to say, you know, all the numbers between 2 and 10, that's an interval. So you would say 2, comma, 10, lowest, comma, highest. Now, the bracket, if it's on the left side, means that whatever this lowest number is it's next to is actually included in the interval. And a parenthesis would mean that it's not, but like everything up until it is. And then over here, same thing, but they're referring to the highest number in the interval. So if you want to say that highest number is included, you would use a bracket. And if it's not, you would use a parenthesis. That's why they can be mismatched because they're referring to different numbers. All right, so I've got two examples to get us started, and then we'll get more practice when we answer some domain and range questions below. So this first one here I have displayed on a number line. I'm going to try to say the interval from 3 to 7, where 3 is included and 7's not. So if we were going to write this as an inequality, we would say this interval includes all x values between 3 and 7, including 3, so x is greater than or equal to 3, but strictly less than 7, right? So 6.99999 is in the interval, but 7's not. So when we say the highest in the interval, we still have to say 7, because no matter how many 6.99999s we put, you could still add an extra 9 and still be in there. So you have to say 7 as like the boundary. So we're going to say lowest number, highest number. The 3 is included in the interval, right? We have a less than or equal to, so it gets the bracket. And then 7 is just a barrier, but it's not actually in the interval. So we put a parenthesis here. So my final answer for interval notation is bracket 3, comma 7 parenthesis. Right? So sometimes there isn't a highest or lowest in the interval. And that's my second example here. So I'm showing on the number line 2 and everything greater than 2, right? So as an inequality, this would just be every x that's greater than or equal to 2. So as an interval, like in interval notation, this would be 2 as the lowest, but then there is no highest because it just goes forever. So when there is no highest number, we'll put an infinity here and it gets an automatic parenthesis. Infinity is kind of a concept and not actually a number, so it'll always have a parenthesis, never a bracket. The 2 is included in this interval. It's not just a barrier, so we'll put a bracket on the 2 side. You can do something similar if it's like all the numbers less than 2, then your lowest would be negative infinity with an automatic parenthesis, and it would be with the 2 as the highest number. Okay, let's see some examples of domain and range. All right, so for these 3 examples, they're given as graphs, of course, and then I am going to answer the domain and range of each, and then we'll worry about formulas at the end. All right, so this first one here is a circle. The domain is going to be all inputs, so in this case, like what appears to be x values used by the graph. So I'm thinking like left and right, what x values do I use? So it looks like the furthest left this graph goes is about here. And then I'm using all these x values until here. So this is -2, +2. And at this point right here, the x value of that point appears to actually be -2, so it's included in the domain. And then this point right here, its x value appears to be +2. So again, +2 is included in the domain, and then any other number between, you can go to at least one point on the graph and find a point that uses it. So I'm going to say -2 to 2, both with brackets because they're included in the domain. Okay, for range, we're going to think similarly, but now we're looking at the y values of all the points instead. So the highest y value looks like 3. And then we go all the way down to -1, and every y value in between is used. So as high as 3, as low as -1. And again, at this top point, it looks like the y value really is 3, so 3 will have a bracket. Same thing down here for the -1. I'll write this sideways. My range is -1 to 3, both with brackets. All right, let's continue to the second example. For domain on this graph, we're assuming because of these arrows, the graph just keeps going up and out forever. Kind of takes a while, but like if I pick a really, really big x value out here, I don't see the graph over there, but I trust, given this implied shape, that if I go up high enough, I'll find a point that has it. So really, this is just using every single x value. So any real number is the domain. So we want to say everything in interval notation. So we're going to say no lowest, no highest. So we just use both of the infinities. This is how we would say all real numbers. All right, for the range though, it's not everything. The lowest y value that gets used would be at the vertex right here, right? So the range is only using the y values from 1 and then up, up, up forever. So our range is 1 to infinity with a bracket on the 1 because it really is being used as a y value. All right, my third and final graph example is the wackiest one. This one, we're going to have to be really, really careful about the domain and the range. So the closed dots on this graph means the point is there, but then it's like breaking. And then this open dot right here means like the point would be there. So you're like really, really close to it. But then the point 1, 4 in this case, it's not there, but it's like taken out. So the point like as close as possible to the right is still there. Same thing over here. It doesn't actually hit this point 3, 2, but it's getting all the way up to it. And then at 3, it'll jump to 3, 1 and keep going. Okay, so the domain of this one is actually everything. So if we kind of follow the graph left to right, this arrow implies that we're going out forever. So all the negative x values get used all the way up to 0 and to 1. The graph stops, but it keeps, like, it kind of picks up, right? So there's not actually a vertical line test failure here because this point's not there. So as soon as you're past x equals 1, you're up here and you're still using x values. Same thing here. The graph drops off, but it picks up at the exact same point and keeps going. So there are no actual x values that aren't getting used somewhere. So the domain is the same as the last one, -infinity to +infinity. All right, so for the range, this downward arrow tells me down, down, down forever, right? So y values that are really negative are getting used. And then this piece of the graph ends at what appears to be 3 or just about. So I would say, all right, we're using up until 3. But at like 3.1, the y value, it does still get used by this chunk of the graph. So really the y values are all the way up to 4, but then not actually at 4. So I'm going to say this would be like a parenthesis on the 4. Okay. And then the rest of this graph is actually kind of redundant. We're like reusing y values that we've already considered. All these points have a y value of 1. But we already thought about that because we passed this point. So my range will be no lowest, so -infinity, all the way up to 4, but with a parenthesis. Okay, so the rest of this video, we're going to talk about answering these questions from a formula, but for the formulas in this class, we're only going to worry about domain. You can also do range questions, but typically it relies on a lot more familiarity with what the graphs look like. So we need to kind of spend the rest of the semester building up our familiarity. So we'll just worry about domain from a formula. And at this point, because we're pretending we've never seen any trigonometry or any logarithms, and for some of us, that may actually be the truth, we only have two domain restrictions that we need to worry about: square roots and denominators. So these first two examples are our models of those two issues. All right, so let me switch back to my red here. All right, so the first domain restriction is the square root. So essentially, like, assume that you can plug in any number to a formula unless something is like stopping you, right? So like I can plug in 6, I can plug in 10, I can plug in 100, and I get some kind of y value out. The problem though is if I plug in x equals, let's say 0, then I have the square root of -5, which isn't a real number. This puts us like in the imaginary numbers. So if we're like graphing on the xy plane, the imaginary numbers aren't there, so this just doesn't plot a point. So 0 is not in the domain of this because it just doesn't have a y value. So there is some restriction here on the domain. All right, so it turns out when you have a square root in your formula, and here it's plus a 1, over here it's on top with a 5, it doesn't really matter what's happening to it, but if there is a root, you take whatever is in the root, so here that's the x minus 5, and you set it greater than or equal to 0. So I can only plug in x values where x minus 5 is greater than or equal to 0. That way I know I'll have an actual real number output. So I need to solve x minus 5 greater than or equal to 0. So in this step, the root has disappeared. I'm just grabbing whatever formula stuff was under the root. And that's what I'll do over here as well, right? The 2x plus 8, I want to set greater than or equal to 0. I solve this inequality the same way I would solve it if there was a regular equal sign, just add 5 to both sides. And I get that x is greater than or equal to 5. So I can plug in 5 or higher, and I'll get an output. So I'm going to write this in interval notation. I want to say everything from 5 and up. And I put a bracket on the 5 because of the or equals here. So from this, we'll always get a bracket. All right, so that's one of our two domain restrictions for now. Anything under a root set greater than or equal to 0 and solve. The second of our domain restrictions will come from a denominator. So again, don't overthink this formula. You can plug in whatever number for x you want, unless you plug in a number that makes the whole denominator come out 0. Then you have whatever over 0, and there is no output, right? Division by 0 just gives no output. So anytime you have a denominator formula, you want to set it equal to 0, solve for whatever x values do that, and then say, okay, everything is cool to plug in except for that number. So we want to say x plus 9 is equal to 0. So of course, that means -9 is the one number I cannot plug in. So really, we're saying everything except x equals -9. In interval notation, that's a little awkward. What you have to do is kind of have everything to the left of it and everything to the right of it, and then just skip the -9. So we're going to do -infinity to -9, but then you put a parenthesis. So you're saying not actually -9 itself, cut it out, and then pick up right on the other side of it and keep going. So anytime you want to exclude just a single number, this is how you'll write it. This union symbol in between just means like this interval and this interval. They're just not physically connected to each other. Okay, so those are our two domain restrictions. Anything under a root, you set greater than or equal to 0. Anything as a denominator, find where it equals 0, and then say everything except that. And then, of course, it gets the most complicated when you have both situations happening at the same time. So in this third example, we have a square root involved, and we have a denominator. So we have to do both of these things and then kind of mush it all together, right? So let's do the 2x plus 8 first. The order doesn't really matter. All right, so because I have a square root, I can see that I need 2x plus 8 greater than or equal to 0. Anything that's under a root gets greater than or equal to 0. It's the denominator that will set equal. All right, so I'll subtract the 8, divide the 2, and I get that for the square root to work out, I have to plug in x values that are greater than or equal to -4. So far, if I want to number line this, greater than or equal to -4. Okay, and now I have a separate issue. I'll switch colors. I also have this denominator situation, right? So greater than or equal to -4 to make sure this works out. But then I also clearly cannot plug in 1, right? So really we're saying not x equals 1. But I want to come back to this picture and show 1 and say like, okay, skip it. So we're going to go -4 to 1 and then do this trick where you kind of skip the 1 and then keep going. Right, so the domain of this one, we're going to do -4 included all the way up to the 1, and then we'll do parenthesis union parenthesis. Pick up after the 1 and then keep going forever. That's as bad as it'll get, at least for now.